Hi everyone. Hi everyone. Good evening, all of you. How are you all? Audio, both are clear, everyone? Audio, both are clear, everyone? Right. So now we'll be continuing our discussion. Right? What we are doing? We are just continuing our discussion on what you can say this all formula revision of this highway engineering. Right? That rigid payment part we are discussing now. Rigid payment part we are discussing, and we'll be continuing our discussion on this rigid payment also. Right? Yes, now we'll be continuing our discussion on this rigid payment only. Right after that, we'll be entering into the last part, that is traffic engineering. You can see, we just observe. Yes, now right. So all formula revision of this highway engineering by myself, you can say your favorite sir RP sir, right? So all of you, welcome to Unacademy. Let's crack it, right? Everyone is ready to crack. All of you are not ready to crack. Everyone is ready to crack or not ready to crack? Everyone get ready to crack, right? Whenever you are subscribing for the pleasant iconic courses, don't forget to use the referral code RP Civil Live, right? What is the referral code you have to use, all of you? RP Civil Live is the referral code you have to use, yes, na? Right. So this is my profile, you can follow me at which, and this is a referral code you have to use, right? Whenever you are subscribing for the pleasant iconic courses, right? RP Civil Live is the referral code you have to use, right? In the description, my profile link is given, and plus subscription links are given, and combat test links are given, and mock test links are given. Everything is given, all of you, right? Whenever you are whenever it is asking for any code, you can use this RP Civil Live, all of you. We just observe, right? Right. So this all India mock test is there from which one? January 2nd to January 30th. Every Sunday you will be there, right? And the last examination you'll be having, this last mock test you'll be having on which one? This is Sunday, coming Sunday. Okay. January 30th is the last day you are having that exam mock test. You can see, we just observe. Right, this combat test also on the January 30th you will be having this combat test, right? January 30th you will be having this combat test also, the last combat for this January month, you can say, is not right? So top 100 people will be having a chance of what? Getting these prizes, right? These interesting exciting gift vouchers you will be getting, and exciting gadgets you will be getting, and all these things, right? Along with that, there is a possibility that you will be getting this 100% free scholarship for plus subscription also, all of you, right? There is a possibility that also, right? So don't miss this, all of you, right? Don't miss this, all of you, try to attend. So these are all the new batches started for various engineering branches, right? These are the civil new batches, you can say. These are the new batches for civil started. So these are the plus courses taken by me. So this airport engineering, today itself it has got completed, and the complete course on this RCC and PSC design, it is going on, you can say. It's not strength of materials free course is going on, and this all formula revision in YouTube is also going on, right? Like that. So now which part we are discussing now? If you just observe this part 30 we are going to discuss now. Is that part 30 we are going to discuss. That part 29 yesterday what we have done, we just remember. Part 29 yesterday what we have done, all of you? We have done what? Right. So this corner loading, right? What is it, you can say? Everyone, if you just observe, this one we have discussed or not, all of you? Yes, this one we have discussed, if you just observe, right? So stresses, right? So nature of this wheel load stresses, right? Nature of this wheel load stresses we have seen. Yes, na? What are the three critical locations identified? One is your interior portion, other one is your corner portion, next one is your edge portions, right? These are the three portions you are having, right? These are the three portions we are having, right? At these three portions, right? At these three portions, what is that condition you can have? At these three portions we are calculating the stresses and everything. Suppose if the wheel load stresses, right? Nature of this wheel load stresses only, na? If the load is acting at interior portion, it is behaving like a simply supported, right? It is behaving like a simply supported slab. So therefore, right, therefore what is that, you can say top compression, bottom tension, right? Simply supported slab, right? Now what is that edge loading? Whenever you are applying that wheel load at the edge, right, what is that, you can say it is behaving like, right, it is behaving like which one? This simply supported beam, right? Simply supported beam. So whenever it is a simply supported beam, top compression and bottom tension, top compression, bottom tension you will be having, and obviously yes, top compression and bottom tension you will be having, obviously. And whenever it is a corner loading, what is that, you can say? When load is acting at the corner, wheel load is acting at the corner, it is bending like a cantilever beam, right? Whenever it is bending like a cantilever beam, top tension and bottom compression exactly reverse to that of first two. Okay, 279. Now lesson 30 today we'll see, right? 279, that 280, what is it you can say, that nature of this wheel load stresses, right? Nature of this wheel wheel load stresses already we have done na? Okay, nature of which stresses you can see if we just observe this warping stresses, right? Warping stresses, or you can also call them as which one, this curling stresses, or you can also call them as which one, this folding stresses, you can say, right? Folding stresses, you can say, right? Like that. Is that clear? Right? Nature of this warping or folding, or which one, nature of this warping or folding or curling stresses. If we just say, right? If we just say, right? Right. So what is that warping, you can say if we just observe? What is that warping if you just observe? Warping is nothing but you are folding like this, na? Folding like this, right? Why this kind of folding will occur if you just observe? These are created due to that daily variation of temperature. Due to which one? This is due to this daily temperature variation. What is that daily temperature variation? What is the daily temperature variation? You can say if we just observe daytime to nighttime and nighttime to daytime, these temperature changes are occurring na. So whenever this daytime to nighttime, nighttime to daytime, these temperature changes are occurring because of this, right? Because of this, right? Because of this temperature changes, it will happen, right? It will happen like that. Okay, right? Okay, right? Isn't it? Right? Isn't it? Now, so if you just observe it, 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 if you just observe here, you can say, what is that? You can say daily variation of temperature, right? Daily variation of this temperature means daytime to nighttime and nighttime to daytime you are having na. Suppose if you just consider this daytime, whenever it is this daytime, who will be there during the daytime? That sun will be there in the daytime na. The sun will be there in the daytime na. Sun will be there in the daytime na. Yes, the sun will be there in the daytime. You consider sun will be there in the daytime, right? Whenever that sun will be there in the daytime, what this sun fellow will cause? That sun fellow will create higher temperature at the top and lesser temperature at the bottom na. And if we just consider here, let us say this is your what? T1, top temperature T1, bottom temperature T2, right? Bottom temperature T2, right? So now what happens if we just have the top temperature T1 and bottom temperature T2, right? So top higher temperature, because sun is directly exposed there, means top is higher temperature. So there at the top expansion will occur, right? At the top that expansion will occur, and at the bottom what happens? Lesser temperature means this contraction will occur now. Bottom temperature, contraction will occur, right? Contraction will occur, right? Top temperature is which one? This expansion, right? Top temperature is expansion and bottom temperature is contraction, you can say like that. Is it clear? Top temperature is expansion, top is higher temperature, this T1 is higher than this T2, right? When that T1 is higher than this T2, what happens? You can say T1 is higher than this T2. What is that? You can say top temperature obviously higher temperature, and it will cause expansion at the top, and bottom temperature obviously it is your which one, this lesser temperature, it will cause contraction, it will cause contraction. So what is that? You can see if you just observe how this expansion will be resisted, all of you. To resist this expansion at the top, expansion means increasing the dimension. How can you arrest this increasing the dimension? By applying tensile resistance or by applying a compression resistance, right? By applying this compressive resistance na. Yes, by applying this compressive resistance, right? So this is your compressive resistance, right? This is your compressive resistance, right? Like that, isn't it? Right? This is your compressive resistance, right? This is your compressive resistance, right? Is it clear? Now to resist that expansion, right? To resist that expansion, we need to have which one? This compressive resistance, right? Compressive resistance, right? Compressive resistance, you can say, right? And at the bottom, contraction. Contraction means a decrease in the dimension. How can you avoid this decrease in the dimension? Decrease in the dimension will be resisted by this tension. Yes or no? Decrease in the dimension will be resisted by this tension or not, all of you, right? Tension, you can say, right? Tension, you can say, right? How can you resist this? That is your tension, right? That is your tension, you can say, right? That is your tension actually, right? Right? So what is the nature of this stresses if you just observe at the top and bottom? At the top, what is the nature of this stresses? What is the nature of this stresses at top and bottom? Right? What is the nature of this stresses? Tell me. Top expansion, right? Top expansion will occur higher because of higher temperature. That expansion will be resisted by which one? This compressive stresses, right? Compressive stresses, right? And bottom contraction will be resisted by this tension, right? Contraction will be resisted by this tensile stresses T, you can say. These are applicable for which one? Interior portion, edge portion as well as corner portions, right? Interior edge as well as which one? This corner portions, you can say, right? This is during this daytime. Suppose if it is during this night time, what happens? Suppose if it is this night time, what is that you can say? Whenever it is a night time, who will be there? That sun will be there or sun will not be there? Sun will be there or sun will not be there actually? Sun will not be there, and who will be there? Moon will be there, na? That mama, Chandamama will be there, right? Sun, moon will be there with his 27 wives, you can say, right? Now which temperature is higher? That T1 is the top temperature and T2 is the bottom temperature. That T1 top temperature is lesser, that T2 bottom temperature is higher if you just observe, right? Why it is like that? Because during the daytime earth will be absorbing the entire temperature, and during the night time it will be releasing it, right? Okay, that is why bottom temperature is higher, and the top temperature is higher, lesser, right? So that is the reason, right? That is the reason, right? That is the reason. Yeah, that is the reason. What is that you can say? That is the reason all the snakes and insects during the night time they will be which one? They will be which one? They will be coming outside, na? Right? So isn't it? So if you just observe why these snakes, insects, everything will come outside during the night, if you just observe, because of which reason? Because of this, because of this, right? Because of this, right? Because of this, which one? Because of this higher temperature at the top only, right? Because of this higher temperature at the top only, sorry, higher temperature at the bottom, earth temperature is higher. That is the reason they could not bear that temperature, so they will come outside, right? Like that. Is it clear? Is that clear, everyone? Right? Like that you are having, right? So now which one, what will happen at the bottom temperature is higher means at the bottom expansion will occur. Top temperature is lesser means what? Contraction will occur at the top, you can say, right? Contraction, right? So now if you just observe, this is your expansion at the bottom and contraction at the top, right? So now tell me, whenever, right, whenever you are having this contraction at the top, how can you avoid this contraction? You can say opposite to contraction we have to create the resistance, means we have to increase the dimension. Increase the dimension means tension must be applied in a, yes, we have to apply this tensile resistance here. And what is that? At this bottom, that compressive resistance we have to apply, right? At this bottom, that compressive resistance we have to apply, right? Like that. Is it clear? So at the top, what is the nature of stress, and at the bottom, what is the nature of stress if you just observe? Right? What is the nature of the stress at top? Top, lesser temperature, contraction. Contraction can be resisted by which one? This contraction can be resisted by this tensile stresses or tensile resistance only, no? Tension, right? Tension or tensile resistance, you can say. Bottom higher temperature expansion, that expansion will be resisted by which one? This expansion will be resisted by this compression, you can say, right? Compression, you can see if you just observe it, isn't it? What is it you can say? That I interior edge as well as corner, right? Interior edge as well as corner, right? You can say, right? Is it clear? For all the portions, right? For all the portions, right? For all the portions we are having this, right? For all the portions we are having the same nature, you can say, right? Is it clear? right? This is the nature of this nature of this warping stresses, right? During daytime, during nighttime, you can say, right? Now this is which one? This is 281. What is the nature of this frictional stresses, if we just say? Nature of this frictional stresses, right? What is that frictional stresses? We just observed when these frictional stresses will be happening. Right? What is that you can see if we just observed? What is that you can see if we just observed? Nature of this frictional stresses, na? Nature of this frictional stresses. What is the nature of this frictional stresses if we just observe? Why these frictional stresses are created if we just observe? These are created due to what? Seasonal variation of temperature. Right? Seasonal variation of which one? This temperature, right? Seasonal variation of this temperature, you can say, right? Like that, isn't it? Now, whenever it is a summer, if you just observe it, whenever it is a summer, if you just observe it, during that summer, what is that nature of temperature? Only you consider the summer effect, don't consider the daytime and the nighttime effect, right? Only summer effect if you wanted to consider means it is having higher temperature. Na? Summer means it is higher temperature, hot conditions, right? Whenever these hot conditions, these higher temperatures are there, what it will result in if we just observe? What is that nature you are having if we just observe of you? So what it will do? Top and bottom higher temperature means, can we say this is top and bottom expansion only, no? Top and bottom expansion only, no? Yes, top and bottom expansion only, right? Top and bottom expansion only, right? Top and bottom expansion only. Whenever it is your top and bottom expansion, right? Whenever it is your top and bottom expansion, that top and bottom expansion means it will be resisted by which one? This expansion will be resisted by this compressive stresses, no, obviously. What is this compressive resistance if you just observe? This is your friction, right? What is the friction? That coefficient of friction into that normal reaction. What is the normal reaction? Right, yes, compressive, right? Anshuman, right? So expansion at the top and bottom will be resisted by this compressive resistance, obviously, right? Compressive resistance, obviously. So who will be acting like this compressive resistance? That friction only will be acting in the form of compression, na? Yes. So what is that you can say? That coefficient of friction into that weight divided by this 2 if you just observe, right? Now what is the nature of stresses at top and bottom? At top and bottom both the same only, na? At top and bottom, what is the nature of the stresses, all of you? Compressive nature only, right? Compressive nature only, right? What is the you can say if you just observe? It is for the interior edge as well as which one? This corner portions it is applicable. Yes, na? For interior edge as well as corner portions it is applicable, you can say. Now, whenever it is winter, exactly opposite to each other, na? Whenever it is winter, what will happen? Exactly opposite to each other. Winter means it is a season of this lesser temperature, or it is a season of this higher temperature. Winter means it is a season of this very lesser temperature, right? Now this is the winter season only, now. Whenever it is a very lesser temperature, top it will become contraction and bottom also it will become this contraction, na? Top contraction and bottom contraction only, right? Top contraction, bottom contraction, right? Whenever it is your top contraction and bottom contraction means, what is it you can say? Contraction and contraction will be resisted by this tensile. Contraction means decrease in the dimension. To avoid this decrease in dimension, we have to apply compressive resistance or tensile resistance. We have to apply tensile. Yes, now if you apply compression, already contraction means decrease in the dimension. If you apply compression, further decrease in the dimension will take place, na? So we have to apply which one? This is a tensile resistance, you can say. So that friction will be acting in the form of what? Tension, if you just observe. Right, this is your friction, right? What is the friction? That coefficient of friction into that a normal reaction, W by 2, total weight by 2. Yes, Anshuman, correct. Now, what is the nature of this stresses at the top and bottom? What is the nature of this stresses at this top and bottom if you just observe? top and bottom, the nature of this stresses will be this tension, this compression C. So this is applicable for which one? This interior edge as well as corner portions it is applicable, right? Interior edge as well as which one? This corner portions it is applicable, you can say, isn't it? So this is about this nature of this stresses, right? Nature of this all stresses, right? Right? Right, this is a nature of which one? This is the nature of this stresses, right? Wheel load stresses nature and warping stresses nature, and which one? What is that you can say? And this frictional stresses nature, right? Nature only is important, or values are also important for us? Values are also important for us, na? Yes, values are also important for us, right? Now if we just observe this wheel load stresses, so who gave this wheel load stresses in the starting? If you just observe wheel load stresses, who gave these expressions? Who gave, everyone? Who gave this? Who gave this wheel load stresses first? Westergaard is the fellow, right? Westergaard is the fellow who gave this wheel load stresses first, right? So, and IRC has modified these formulas if you just observe, right? Westergaard's formula, and next one is your which one? This IRC formula. Westergaard has given some formula and IRC has modified this formula if you just observe, right? What is the Westergaard formula if you just observe first one? What is the Westergaard formula? SI, right? What is that? SI, you can say that is stress at interior portion, wheel load stress at this interior, right? S is the symbol for stress, or S or sigma, any symbol we can use for this stress, right? So what is that you can say? 0 point, right? It is 0.316 P by H square. P is the wheel load you are having, H is the thickness of the pavement, into what is that you can say that 4 log L by B to the base 10 plus what is that? Plus 1.069, right? Like that, right? Plus 1.069, right? Yeah, hi Lina. Right, plus 1.0, which one? This is 69, you can say. Now, here if we just observe for this IRC formula also, right? What is that IRC formula? This is the same, na? Right? This is the same, na? This is the same, na? Yes or no? This is the same, right? 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 This is the same, na? Yes, this is the same, because right? Interior stress expression given by this IRC also will be same as that of your Westergaard's equation only, right? There is no change in that expression, right? But what is that you can say? Second one, edge. Whenever it is this edge loading, SE or this is sigma E, right? If you wanted to say this is sigma E or SE, right? What is that you can say? What is that? Sigma E is nothing but your stress at the edge, or SE, right? Stress at the edge, right? Any symbol you can use, right? Sigma or S you can use, right? What is that you can say? If you just observe 0.572 P by this H square into what is that you can say? 4 log L by B to the base 10 plus what is that? 0.359, right? 0.359 you are having, right? But what happens here? If you just but what happens here? IRC is using the same formula or different formula? IRC is using the same formula or different formula? IRC is using different formula, na? For only for interior loading the same formula is used, but for this edge loading it is a different formula used by IRC. You can say a different formula used by IRC, right? What is that formula? You can simply just observe, it is 0.529 that P by H square into what is that? P by H square into 1 minus 0.54 mu is nothing but your Poisson's ratio, right? Into what is that you can say? Into very big equation, right? 4 log L by B to the base 10 plus what is that? Log B to the base 10 minus what is that? 0.404, right? Sir, do we need to remember all these equations? No, but you remember approximate variations of this expression, right? Approximately how? So you should identify that stress is directly proportional to P and inversely proportional to H square. Those things we have to identify, right? And what are the parameters involved in this, right? What are the factors involving in this, right? Those things you have to remember, right? But don't remember the exact expression, right? No need to remember this exact expression. You can say we just observe. Yes, now. Now, what are the corner stresses if we just say? What are the corner stresses if we just say? Sigma C or SC will be equal to, right? These equations you have to remember definitely, right? Either it is a Westergaard or it is IRC formula. You have to remember these equations definitely, right? What is that you can say? That 3P by H square, P is the V load, H is the thickness of the pavement, 3P by H square into 1 minus, what is that you can say? That A root 2 by L, A root 2 by L whole power how much? 0.6, na? 0.6 you can say. And what is that? IRC has given how much formula? Sigma C is equal to that, SC will be equal to that 3P by this H square into, right? What is that you can say? 1 minus that A root 2 by L whole power how much? 1.2 is given by this IRC, right? Like that. That is the only change you are having, right? This is the only change you are having, right? Like that. So edge formula is completely different, right? Edge formula is completely different, but interior formula is same. Corner formula is little bit modified, you can say, right? So once it is done, tell me. So what is that you can say? That SC by this Westergaard is lesser than which one? This corner stress by this, which one? This corner stress by this IRC formula, right? So like that. So which one is more conservative? You can say IRC formula is more conservative, means, right, more safe formula if you just observe. It's not, this is 282 and 283. What is the point you can say? IRC formula. Because based on the observation, these Westergaard's formulas are not giving the correct results which are matching with the practical experimental results. So that is why they have modified these values, right? IRC formula are which one? This more conservative than Westergaard's. Conservative means the safer side, higher stresses it is giving. More conservative than which one? Westergaard's formula. Why it is like that? Since that A root 2 by L is lesser than 1, right? Since that A root 2 by L is lesser than 1, whenever any value is lesser than 1, its lesser power will have higher value compared to its higher power. Because that A root 2 by L is lesser than 1, because that A root 2 by L is lesser than 1, what is that you can say? A root 2 by L power 0.6 will be higher compared to this power 1.2, right? That is the reason IRC formula will be giving the higher stress compared to the Westergaard's formula if you just say. Yes, na? So this is what you are having, right? This is what you are having if you just observe. Yes, na? Right, now 284 and what is the you can say if you just observe this warping stresses? What are the values of this warping stresses? Who gave this warping stresses? Warping stresses are given by this fellow called as your Bradbury, right? Who gave these formulas, all of you? Bradbury has given, na? Bradbury has given this formula, right? Bradbury has given this formula. Excuse me. What is that you can say? STI means temperature stress at interior, or SWI, right? What is the meaning you can say? Temperature stress or warping stress at the interior, right? What is the temperature stress or warping stress at the interior portion? E into alpha into that delta T, right? Delta T is nothing but your change in temperature divided by which one? 2 into what is that you can say? That Cx plus this mu Cy, Cx plus this mu Cy divided by this 1 minus mu square, right? This is what, right? And what is that STE means temperature stress at the edge or warping stress at the edge, right? How much it comes to be? Two edges you are having, na? What are the two edges? E alpha delta t by 2 into Cx, or E alpha delta t by 2 into which one? This is C, right? 2 into which one? This is C, right? First one is which one? First one is along the length. First one is in the length direction. Second one is in the width direction. Y means what? This is in the width direction. You can say it. Y means width direction. You can say it. Now what is that? STC or SWC? Warping stress or temperature stress at the corner. If you just observe, it is nothing but your E alpha delta t by 3 into 1 minus mu into what is that? You can say under root that A by L. If you just observe, right? Like that. So these are which one? These are the corner stress, these are the warping stress formulas if you just observe, right? These are which formulas you can say? These are the warping stress formulas given by this Bradbury if you just observe, right? Is that clear? Right? Is that clear? Right? Is that clear? Is that clear? Right? So now these are your warping stresses, right? Now what are these frictional stresses if you just observe? What are the frictional stresses if you just observe it? These frictional stresses are which one? What is the frictional stresses, everyone? So that SFI and SFE, right? What is the meaning of this? Frictional stress at the interior portion and frictional stress at the interior portion or frictional stress at the edge portion, right? Both are same, na, right? Both are same, you can say, right? Both are same, you can say, right? Because if you just observe, whenever you are having this friction, na, so here if you just observe, this portion is subjected to more effect, you can say. This portion is subjected to maximum stress, right? What is the stress at the corner? 0, na? And this is your interior portion and these are your edge portion, right? These are subjected to which one? This maximum stress, right? Here also this central portion is subjected to which one? This central portion is subjected to which one? This maximum stresses, right? Maximum stresses, right? So this is your edge portion and this is your interior portion and these are your corner portion, right? Corner portion not contributing that much towards the friction, so frictional stress at the corner is 0, but frictional stress at the edge and interior both are same and maximum. What is that you can say? What is that you can say? F gamma C Lx by 2, it is along which one? It is along the length. If it is F gamma C Ly by 2, right? If it is along which one? It is along the width, right? It is along the width, you can say, right? F gamma C Ly by 2 along the width, right? These same formulas are applicable for both summer and winter. For both summer and winter, both same formulas are applicable, right? Now tell me, what is the frictional stress at the corner? SFC will be approximately equal to 0, right? Because that central portion connecting the edges will be subjected to maximum stress, right? Maximum stress, right? Therefore, so do you find any stress at the corner, or we don't find any stress at the corner, right? We don't find any stress at the corner. We don't find any stress at the corner. We don't find any stress at the corner, you can say, right? We don't find any stress at the corner, you can say, isn't it? It's not. We don't find any stress at the corner if we just observe, right? Like that, isn't it? Right? Now, friction stress at the corner will be 0, right? Because it is not that much resisting, because it is not that much resisting, you can say, right? Now, so what is the point you can write? One more point, 286 point. What is the point you can write here, all of you, if you just observe it? The nature of this stresses, right? Whenever you are considering this nature of this stresses, which one is having this maximum stress? Frictional stress is what? Maximum at which one? Frictional stress is maximum or highest at which one? This interior and edge both are same. Okay, interior and edge both are same, na? And least or minimum at which one? Corner. Okay, minimum or least at corner, right? That is your least and that will be 0, you can say, right? That is your maximum, means that highest, you can say, highest. Now 286, 287, if you just observe, what is that you can say? Wheel load stress is, right? What is that you can say? That wheel load stress, that wheel load stress is highest at which one? Highest at which one? Highest at the corner, right? Why it is at the corner? Because it is creating, right? Because it is creating which one? This bending effect only. Now wheel loads will be creating this bending effect, right? Wheel loads will be creating this bending effect, right? Those bending effects, right? What is that you can say? Wheel loads will be creating this bending effect, right? Those bending effect is higher at the corner. Whenever compared to the simply separated and simply separated, corner will be having more bending effect now, so more bending stress, right? Highest at the corner and less at which one? Lesser at which one? Lesser at this edge and least at which one? And least at that interior, if you just observe. Because at the interior, if you just observe, whenever that load is acting at the interior, more material is available on the all sides. More material is available on the all sides means less stresses only comes into picture, na? Yes, but for this corner there is no resistance we are having, right? If this is a corner, this side is discontinuity, this side discontinuity, right? Both sides it is discontinuity, means what is that you can say? It is least resistance, therefore highest stresses we are having, na? Yes, obviously, right? Right, edge in between these two. Now tell me, this is 288. If you just observe this warping stresses, who will be resisting these warping stresses? Let us say during daytime, summer, higher temperature. So okay, we'll go back to this. If you just observe, what is that you can say? The nature of this warping stresses, if you consider during daytime, what is happening? During daytime, what is happening? Top higher temperature expansion, bottom lesser temperature contraction, right? It is subjected to this folding like this. Now tell me, it is folding in which direction? You can say, if you just observe, it is folding or warping in, it is trying to get folded in this downward direction like this. Because of this, it is getting down, it is folding down, right? So it is, you can say, that warping down. Warping down or folding down, you can say warping down or folding down, right? Whenever it is getting folded like this, who will be resisting that? Self weight will be there. That self weight will try to pull it in the downward direction again, right? Warping down. Here what is happening? At the bottom, night time, it will be trying to get folded like this, right? Because of this folding, what happened? This will be lifted, but that self weight will allow it to lift, or it will try to move it in the downward direction. It will try to move it in the downward direction, right? So it is your warping up, or it will be getting folded like this in the upward direction, right? Warping up. This is your warping up, right? This warping, both warpings are resisted by this self weight only, right? You can say. So what is it you can say? That warping is resisted by this self weight. Warping is which one? This warping is resisted by which one? This is self weight, you can say. So therefore, what is that warping stress? Where is that warping stress highest then? Therefore, warping stress is which one? This. Therefore, this warping stress is highest at which location? Highest at the interior portion. Why it is highest at the interior portion? If you just observe, because at the interior portion, you are having that more self weight. More weight means more resistance, so more stress, right? And it is lesser at which one? Lesser at which location? Lesser at the edge portion, and at the corner, if you just observe, the self weight effect is lesser. So therefore, this is your least at which location? Warping stress is least at the corner, you can see, if you just observe, right? These wheel load stresses and warping stresses are exactly opposite in nature, if you just observe, right? Wheel load stress is highest at corner, warping stress is least at corner. Okay, wheel load stress is least at the interior, and warping stress is least at the corner, you can see, right? Like that. Is it clear? So this is how you are having this kind of situations, right? Like that. So in this pavement design, what we are left with? We are just left with this joints only. Okay. We are just left with this, which one? This rigid pavement joints only. Okay, 28. I'll just write the list of these joints, and in tomorrow's class we'll see these what are the different joints you're having, right? Different connections or different joints you're having, if you just say. Okay, joints in rigid pavement. What are the different joints in rigid pavement? You can say first one is your longitudinal joints, means it is provided along the length of this road. Longitudinal joints, or these are mainly, we can say it as which one? This warping joints. Now what are the other type of joints? You can say these are your transverse joints. Transverse or lateral joints. What are these transverse or lateral joints? You can say one is your expansion joints, other one is which one? This contraction joints. One is your expansion joints, other one is your contraction joints, because right, like that. Okay, right. Yeah, Ramdel, hi. So this is what we are having. If you just submit, this is what we are having, right? Yes, I am good. How are you? Right. So this is what we are having, right? So like that. So in tomorrow's class, mostly that rigid pavement will get over, right? Tomorrow's class, that rigid pavement part will get over. Anyone having any doubts? If no doubts, I'll be closing the session. Shall I close the session? I'll be closing the session. Thank you all of you. In tomorrow's class, I'll be just discussing what this.